Hello friends, good afternoon everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel Dr.Satendra Kumar. Dear friends, if you want this type of videos related to mathematics for higher level, then you need to subscribe, share and like my videos and my channel. Today we will discuss short type question based on complex variable differentiation or Mobius transformation. Now short questions. There are short questions. Now question number 1. Find the fixed point. Find the fixed point or invariant point. Invariant points and the normal form. Normal form of the following bilinear transformation. BT bilinear transformation. Part number first. Bilinear transformation W equal to Z minus 1 upon Z plus 1. Now second bilinear transformation W equal 3IZ plus 1 upon Z plus I. Now third bilinear transformation W equal 2 plus I into Z minus 2 upon Z plus I. Discuss the nature of the transformation. Nature of the transformation. Okay, student. Now, answer. First part. For fixed point or invariant point, we put in given transformation W is equal to Z. That is for fixed point, Z is equal to, that is W is equal to Z. Z minus 1 upon Z plus 1. That is Z square plus Z is equal to Z minus 1. Now Z cancelled by this. That is Z is equal to plus minus I. Now there are two fixed points. Are two fixed points. Now for normal form, since W is equal to Z minus 1 upon Z plus 1, therefore Z minus I, that is Z minus alpha, Z minus 1 upon Z plus 1 minus I. Now by solving, Z minus 1 minus IZ minus I upon Z plus 1. Similarly, for minus I fixed point, this is equal to Z minus 1 upon Z plus 1 plus I. Now Z plus 1, Z minus 1 plus IZ plus I. Okay. Now divide W minus I upon W plus I. This is equal to Z minus 1 minus IZ minus I upon Z minus 1 plus IZ plus I. Since we noted there are two fixed points, alpha and beta, then normal form can be written as W minus alpha upon W minus beta is equal to this. Now factorize. Taking common z in numerator 1 minus I now minus I common 1 minus I. Similarly in denominator z into 1 plus I and taking the common I 1 plus I. Therefore 1 minus I common z minus I upon 1 plus I common z plus I. For simplification, we divide and multiply 1 minus I both sides. Now here square z minus I upon z plus I as well. Now solving minus I z minus I upon z plus I. This is normal form. Normal form. For nature or transformation, since lambda equal, this is compared by alpha minus beta upon alpha minus beta, alpha minus w minus alpha upon w minus beta is equal to lambda into z minus alpha upon z minus beta. Now here lambda equal to minus I. Now modulus of lambda equal to 1 and transformation is elliptic. Transformation is elliptic. Now next part, for fixed point W equal to 3iz plus 1 upon z plus I, that is z is equal to 3iz plus 1 upon z plus I. Now cross multiply z square plus iz equal to 3iz plus 1. Now z square minus 2iz minus 1 is equal to 0. That is z square minus 2iz plus I square. Now factorize z square minus iz plus I square, this is equal to 0. Now z is common, z minus I, here minus I common, z minus I, this is equal to 0, the z minus I whole square. That is z is equal to I is the only one fixed point. Hence z is equal to I is the only fixed point. Now for this fixed point, we calculate lambda minus or w minus I. This is equal to 3iz plus 1 upon z plus I minus z plus I minus I. Now taking LCM, z plus I, 3iz plus 1 minus iz plus 1. Now solving 2yz plus 2 upon z plus I. Now 1 upon w minus I, this is equal to 2z plus I upon 2iz plus 2. Now first, this is the same degree polynomial. Now we divide z plus I with 2iz plus 2. Now we get minus I by 2 plus 2I upon 2iz plus 2. Okay, student? Now taking here 2I common in denominator, that is 1 upon w minus I equal to minus I by 2 plus 1 upon z minus I. This is 1 upon z minus I by 2. This is normal form. Normal form. Since there is only one fixed point, now given transformation is parabolic. Given transformation is parabolic. Now third part is for invariant point or fixed point, z equal 2 plus iz minus 2 upon z plus I, implies z square plus iz, this is equal to 2 plus I into z minus 2. Now iz cancel by this iz, therefore z square minus 2z minus plus 2 equal to 0. This is a quadratic equation in z. There is no factorize. Now we can apply Satendra formula. Minus b minus minus plus minus b square, that is minus 2 square minus 4 into a is equal to 1, and into c, where c is equal to 2 upon 2 into a. Now this is equal to 1 plus minus I. Okay? There are two fixed points, 1 plus I, 1 minus I are two fixed point. Okay, student? Or invariant point. Now for normal form, we calculate normal form. W minus 1 plus I, this is equal to 2 plus I z minus 2 upon z plus I minus 1 plus I. Now taking LCM, then we get z plus I is LCM, 2 plus I into z minus 2 minus z minus I minus iz plus 1. This is equal to z minus 1 minus I upon Z plus I. This is the value of W minus 1 plus I. Okay. Second invariant point, W minus 1 minus I, this is equal to 2 plus I Z minus 2 upon Z plus I minus 1 plus I. Now taking LCM, Z plus I. Now 2 plus I into Z minus 2 minus Z minus I plus IZ minus 1. Now Z plus 2IZ minus 3 minus I upon Z plus I. Okay. Now Z plus I is same. Now here Z minus 1 minus I. Now use plus I, that is we add 1I and subtract 2I, 1I, then we get, now 2IZ is same, 2IZ minus 2, now 1 use here, now remaining 2 quantity, now 2I, therefore Z plus I and Z minus 1 minus I plus 2I common, Z plus I minus 1. This is equal 1 plus 2I into Z minus 1 minus I upon Z plus I. This is the value of W minus 1 minus I. Now dividing W minus 1 plus I upon W minus 1 minus I. This is equal Z minus 1 plus I upon 1 plus 2I into Z minus 1 minus I. This is equal 1 minus 2I, multiply and divide, then we get 1 minus 2I, and in denominator we get 5. Z minus 1 plus I upon Z minus 1 minus I. This is normal form. Normal form. Since lambda is equal to 1 minus 2I upon 5, neither lambda is real nor modulus of lambda equal to 1. Okay? There is no hyperbole. Hence, in this situation, the transformation is losodromic. Okay, student. Now, question number 2. The set of all bilinear transformation which have fixed point as -1 and +1 is answer. Option A option tz equal az plus b upon bz plus a, where a square plus b square is equal to 0, a square minus b square equal to 0. Now b part, tz, that is w, az plus b upon bz plus a, where a square minus b square not equal to 0. Now C option, w equal to tz equal az plus b upon bz plus a, where a square plus b square not equal to 0. Now D part, w is equal to tz equal to az plus b upon bz plus a, where a square plus b square is equal to 0. Okay. Now solution. We know that w is equal to tz equal to az plus b upon cz plus d. Is a linear transformation only when AD minus BC is not equal to 0. Okay. Now by given fixed point, we use here, since z is equal to 1 in this, that is t1 equal 1, t1 is equal to 1 equal implies that here a plus b equals c plus d. Now t1 is equal to 1, now z is equal to 1, imply that we get a plus b minus c minus d equal to 0, equation number first. Now for second invariant point, second invariant point is -1, that t minus 1 is equal to -1, imply minus a plus b equal minus c plus d, that is minus a plus b minus c plus d equal to 0. This is equation number 2. Now solving from equation first and second, from equation first and equation second, we get a equal to d, b equal to c. Therefore transformation tz equal az plus b upon bz plus a, where a square minus b square not is equal to 0. Therefore option B is correct. Option B is correct. Now next question, question number 3. Let the transformation C naught infinity to C naught given that tz equal infinity, when z is equal to infinity, comma c is equal to 0. Value of tz a upon c, where z is equal to infinity, comma c not equal to 0. Okay. Now infinity again. This is minus infinity here, now plus infinity here. Z equal to minus d upon c, comma c not equal to 0. Now dz plus b upon cz plus d, this is the fourth value. In the other case, that is otherwise, now continue the question. Then which of the following is oblique are true? A part, T inverse is a bilinear transformation. B option, T inverse is not a bilinear transformation. C option, T inverse W equal minus dW plus B upon CW minus A, or D option, none. Now solution. Since Tz is 1 1 and onto mapping, is 1 1 and onto mapping, from C naught infinity to C naught, hence T inverse exists and is given by since W is equal Tz, if and only if Z is equal to T inverse W. Okay. Therefore W equal Az plus B upon Cz plus D. Now by calculating, then we calculate value of Z equal minus dW plus B CW minus A. Now here AD minus BC is not equal to 0. Therefore, now this is the same procedure. AD minus BC is not equal to 0. Okay. Imply T inverse W equal minus dW plus B upon CW minus A, where AD minus BC is not equal to 0. So A and C both are correct. Both are true. Now question number 4. Every binomial transformation every bilinear transformation transforms A option, circle into circle, circles into circles. B option, circles into lines. C option, lines into lines. D option, lines into circles. Okay. Now to determine the correct option, let bilinear transformation Tz equal to W equal to Az plus B upon Cz plus D, where AD minus BC is not equal to 0. BA bilinear transformation if C is not equal to 0. C is equal to 0 in first case. Then Tz equal A upon D Z plus B upon D equivalent to Az plus B, where capital A is equal to A upon D or capital B is equal to B upon D, implies Az plus B being linear maps circle and lines into circle and lines in bracket. A line is a circle with infinite radius. Okay, this is the correct in first case. Now second case, if C is not equal to 0, then Tz equal to W. Now taking A common, Z plus B upon A. Now C common in denominator, Z plus D upon C. This can be written as A upon C plus BC minus AD upon C into 1 upon CZ plus D. By dividing, then we get only. Now Tz equal A upon C plus BC minus AD upon C square. Now 1 upon Z plus D upon C. Put Z1 is equal to Z plus D upon C, Z2 is equal to 1 upon Z1, and Z3 equal BC minus AD upon C square Z2. We get Tz equal A upon C plus Z3, which is of the form which is of the form W1 equal to Z plus alpha, comma W2 is equal to 1 upon Z and W3 is equal to beta Z, which shows that every bilinear transformation is the resultant of bilinear transformation with simple geometric imports. Thus, a bilinear transformation, that is BT, maps circles and lines into circles and lines. Imply A option, B option, C option, comma D option are true. That is, all options are true. Now, question number 5. Let the map W is equal to 1 upon Z, then option number A circle not passing through origin in Z plane is mapped on a circle in W plane, not passing through origin. Now B part, a circle passing through, B option, a circle passing through origin in Z plane is mapped on a line in W plane, not passing through origin. Now C option, a line not passing through THROUGS, passing through origin in Z plane is mapped on a circle in W plane passing through origin. Passing through origin. Now D option, a line passing through origin in Z plane is mapped on a line in W plane passing through origin. Passing through origin. Answer. Now repeat. A circle not passing through origin in Z plane is mapped on a circle in W plane not passing through origin. D option, a circle passing through origin in Z plane on a line in W plane not passing through origin. This is the circle passing through the origin, but mapped line is not passing through origin. C option, a line not passing through origin is mapped on a circle in W plane passing through origin. Now D option, a line passing through the origin in Z plane is mapped on a line is a W plane passing through origin. Now here option A, B, C, D are true. Okay, student.